inviting me. It's a privilege to spend some time with. I know all of you to some degree, and I sure resonate with some of the issues that the challenges you're dealing with, and the struggles that you're trying to sort of balance on top of COVID with culture change and shifts in priorities, and some of them competing priorities, like enhanced short-term grids. At the same time, you're trying to evolve into probabilistic space. So I look forward to the conversation, and hopefully we'll come out with some insights that those of you who are leaders in the field, are trying to sort of sort out. So many of you already know, over the past couple of years, 2.5 years or so, the OPG, in collaboration with SPC and several subject matter experts from among the Sioux ranks, developed and conducted a series of proof of concept experiments that were designed to demonstrate the benefits of skillful mesoanalysis. In fact, a couple of your Con East Sioux who are here, Dan and Brian, were part of that original think tank. So David asked me to sort of talk a little bit about where we are now, and the advent of a national initiative that Greg sort of alluded to in the opening comments. And in addition, maybe just a quick sort of overview about exactly what it is we're advocating for. I think most of you, if not all of you, are aware, but just to make sure that we are, and perhaps even to provide you an example that you could use if you have forecasters who kind of need that clarity. So circling back to the beginning very quickly, the primary objective, of course, was to immerse forecasters in this combination of advanced training followed by realistic simulations that would test the capability for incorporating dedicated mesoanalysis in an operational setting. And it was our hope to establish a clear sense for the value of that practice toward enhancing operations and services, and then champion those skills across the country, the use of those skills. So feedback from the Sioux and participating forecasters suggested the experiments were successful. In fact, the OPG was funded to conduct 2 additional workshops this year, but of course those plans were halted because of the COVID-19 pandemic. But still, the demand for spreading these skills has continued to grow, as evidenced by stuff that, like you guys were trying. There are numerous ways that boot camp participants and Sioux who were just interested in this practice have served to sort of champion through teaching and practicing real-time mesoanalysis in their home offices. And I'm really interested to hear, both you've already alluded to some of the successes, some of the challenges, and some of the ways that maybe it got in the way when you were, for example, experimenting with chat rooms. So I hope we can talk a little bit more about that to inform what we ought to be promoting as best practices as this project moves on. At any rate, in the springtime, J.J. Brost, as you know, was hired as my successor to lead the OPG, and I had planned to retire at the end of May. But around the 1st of April or so, the director of the STI portfolio asked if I might consider delaying my retirement to help him lead a couple of projects that he felt were both urgent and important. One is related to multi-year strategic planning, which is not the topic of this conversation. But the other one is to lead an initiative that's aimed at implementing mesoscale analysis connected to enhanced IDSS nationwide. And so the idea is really to take an intentional approach toward utilizing the expertise of Sioux like yourselves, and enlist your help in organizing resources, in creating a library of customizable foundational training, to oversee the development of a series of experiential exercises that are broadly accessible to the forecaster community and can serve to build proficiency in the practice of these skills. I mean, you really can't get good at this unless you keep in practice. The reason SPC is the best at mesoscale analysis is not because they're any smarter than you. It's because they do this stuff every day. So we want to find ways to help people build proficiency both within the local office and in a collaborative way across CWA boundaries. So sometimes when I talk about wanting to champion mesoanalysis, there are questions about whether it really deserves so much attention. So, whether we should really be investing in this in the face of all these other competing priorities, some of which you already mentioned in your opening comments. And there are other training needs as well. And there is, let's face it, there's the likelihood that we're going to have a shrinking budget. So, and many argue it's nothing new, and they're right. I mean, Doswell published a 2-volume set like 30 years ago about mesoanalysis, and it was really the core of what I used to do when I was a lead forecaster in a severe forecast unit with the Air Force back in the 80s. So it's true that we've been doing it for a long time, but it's also true that there are new opportunities to sort of modernize what that practice looks like, particularly with the advent of things like high-resolution model sets and even the early versions of Warn-on Forecast, and of course GOES 16 and 17 imagery, and data fusion decision aids like Prob Severe model and those kinds of things. So before I go into a little more background about what are the STI plans for a national initiative and enlist your thoughts about contributions that you guys make or ways that it might help you, I thought it might be helpful to take a brief step back and illustrate just a few applications of skillful mesoanalysis to ensure we are all on the same page about exactly what I'm advocating for and why we should champion its practice as a critical value-added role for the forecaster of the future. And it may also foster some debate about whether we do this and how do we do this and also do enhanced short-term grids, which I'll just tell you right now I'm not a huge fan, but that's neither here nor there. So I want to take a look at a specific case and demonstrate some ways a forecaster might, through careful observational analysis, infer some important details about how the environment is evolving. And then connect those insights to anticipating the development of severe weather hazards and communicate associated threats, precise, targeted DSS message. So I selected a case. It's one that we used as kind of a practice case in the boot camp experience. It's from July 19th, 2018. And it's relevant to a number of mesoanalysis challenges. So we'll focus our attention on central Iowa, where SPC had identified a slight risk of severe weather based on a 15% probability of damaging wind and large hail with a 2% probability of tornadoes. So the synoptic scale pattern very quickly on this day presented an unseasonably dynamic setup as a 90-knot jet digging into the backside of a negatively tilted shortwave over the upper plains. And while the backside of the trough is not obviously the best location for synoptic scale forcing for ascent, there was evidence of large-scale forcing or the vicinity of the nose of this jet stream. And, of course, that anomalously strong flow would contribute, as you might expect, to unusually robust deep layer shear for the middle of July. So as shown on the upper right panel, a 500 millibar low was moving across southern Minnesota, and lower levels showed moderate flow. 850 winds, for example, were from the west-southwest about 15 to 20 knots from northern Missouri through northward through Iowa. And there was an expansive area, as you can sort of see on the lower right, of warm, moist air covering most of the central and northern plains with surface dew points anywhere from the mid-60s to 70s. Now, if we take a quick look at the Omaha sounding to the west of our area of interest, it shows rather moist and stable surface conditions, but obviously you can see that that moisture is really shallow. And the flow just above the surface is dominated by west-northwest winds on the backside of that shortwave. So not super favorable, but this sounding is clearly too far west to be representative of the conditions in our area of interest. So if we go off to the next sounding to downstream to the east is Davenport on the other side of Iowa, and their 12Z data shows more moisture aloft than the Omaha sounding, leading to a pretty modest lapse rate. And of course, you can see the flow at Davenport is quite weak through all levels. Of course, that also is not really representative. It's too far east to be considered representing, the area we're most concerned about. So if we look at a proxy sounding from the RAP, here's a 17Z RAP analysis sounding near Des Moines. It paints a much different picture, right? The boundary layer's quite unstable already. ML Cape is in excess of 1,700 joules per kilogram. Effective inflow layer is about a kilometer and a half deep. Low-level flow is modest, as noted earlier, but there is considerable veering in direction, yielding effective SRH of a little over 200 meters squared per second squared. So let's take a look then at the visible imagery. And I don't know how this is coming. This is animating, but I don't really know how it is being portrayed with the bandwidth that we're dealing with Google Meet. But
it looks really good, Ken.
Okay, very good. So a number of key features worth noting here. There's an advancing boundary clearly visible just to the west and northwest of Des Moines, which is, close to the center of the state there, if you're not familiar. And convection is already forming along it and in its vicinity in northern Iowa. And there are a few, looks like there are a few attempts at convective initiation west of Des Moines in the moist sector ahead of the boundary, but those tops are being orphaned. So it indicates there's some capping in place. It implies the mesoscale lift is not sufficient to sustain convective growth in the presence of that capping, but we would expect it to, the capping inversion to continue weakening from that orphaning process due to evaporative cooling as subsequent updrafts slowly erode that warm layer aloft. Near and to the east of Des Moines through this area, if you can see my cursor, you can see the presence of these billow clouds at different heights, nearly perpendicular to each other. So that crisscrossing of stable billow clouds, which are oriented perpendicular to the shear vector in that layer, are, of course, as you know, an indication of the turning of the shear vector with height. So, that implies that in that region, there's a rich reservoir of low-level helicity if that air were to be ingested into an updraft through surface-based effective inflow. So, indeed, the observed 0Z Davenport sounding bears out that sort of prediction or that expectation, showing a deep surface-based effective inflow layer with helicity in excess of 300 meters squared per second squared. I apologize if there's clunky noise in the background. I think the garbage guys are out front. So anyway, let's synthesize these insights derived from our mesoanalysis. So just pausing that animation here in a still, we can identify a threat area that within this slight risk of maybe 100 or 150 counties across the Midwest, we can identify a threat area that's limited to maybe a dozen or so, right? So the advancing surface boundary where the viz image depicts agitated cumulus towers forms the western limit to our threat area. Over to the east, cooler temperatures coupled with the laminar character of the low clouds in the scene there over the eastern third of the state, that suggests it's more stable air that should probably bound the eastern edge of our threat area, right, at least for the next several hours. To the south, there's an area of clearing that's associated down in northern Missouri. You you can see that it's the air mass, although the temperatures and dew points suggest the potential for pretty decent moisture and instability. All of that clearing there is really convectively processed air resulting from morning convection that happened to the south over Missouri, which you would know about if you were, monitoring the situation for the last few. So while the air mass here could certainly recover sufficiently to support convective hazards in time, for the next few hours, it's safe to assume there's no significant threat of surface-based convection from that region. And then off to the southwest, there's some uncertainty as to where the southwest extent of the threat would be, but that advancing boundary should narrow the corridor, fairly quickly within the next hour or so. So, accounting for some eastward progression of the surface convergence zone prior to the onset of severe weather, that leaves us with this zone of enhanced threat for damaging winds, for large hail, and potentially even for tornadoes, encompassing an area that looks something like this. So if I count right, I think it's somewhere around maybe 12 to 14 counties. So it's a pretty nice narrowing of the primary zone where we expect severe weather over the next, say, 2 to 4 hours. And we've seen indication for the potential here of rotating updrafts. We might want to dig a little deeper to determine whether these storms can remain discrete long enough to pose an appreciable tornado threat before we craft exactly what our messaging looks like. So as a reminder, you're well aware the three primary factors that drive the likelihood of achieving persistent discrete convective mode are these, assuming first that updrafts have sufficient residence time in a region of moist, unstable surface space effective inflow of air. The three drivers in order of importance are a boundary relative storm motion directed off the initiating boundary, orientation of deep layer shear to the initiating boundary, and storm relative anvil level flow. So if we zoom in on a procedure that looks something like this, can be used, that can be used as a decent diagnostic to assist with that sort of assessment. So the computed K field in the kind of gray and magenta, where it goes from purple to gray and into sort of a magenta, that's kind of delineating where we might expect the surface boundary to be in the next couple of hours, and reasonable estimate at least. And the 7 to 300 millibar mean wind, which is shown by the black vectors, can then be used as at least a first guess for storm motion. Deep layer shear then is indicated by the light blue wind barbs, and you can see both of those vectors have a strong component orthogonal to the initiating boundary, right? So, and of course, in addition, the magnitude of the bulk shears, it's like 40 to 50 knots, it looks like over central and southern Iowa, would certainly be sufficient to support supercells. If we then toggle on these yellow arrows, which are 2 to 300 millibar storm relative wind vectors, assuming that's a pretty good proxy for the orientation of anvil plumes, that flow too is oriented very much perpendicular to the initiating boundary, although it's not very strong. But taking all of those factors into account, there does appear to be a significant threat for discrete storms with rotating updrafts in this vicinity, moving through an area that's quite unstable and in the presence of pretty strong 0 to 1 kilometer helicity. So that suggests at least an elevated potential for tornadic supercells. So you might want to include that in whatever messaging that you craft. And that potential did, in fact, come to pass. There were 2 EF3 tornadoes in south central Iowa over the next 2 to 3 hours. But, going back to the issue of what did we do to clearly delineate our threat area and potential hazards and then communicate the useful information to decision makers. So once we determined this, we would probably want to, I think, obviously, ensure all members of the internal warning team are on the same page, which, as you have already alluded to, is increasingly challenging right now until we're post-COVID and can get face-to-face with our teams while they're dealing with the severe weather. But next, then, it would probably be prudent to hold some kind of a brief coordination call with SPC, just to notify them of your intent to cover a short-term conditional threat of tornadoes in a very focused area, but that may have a higher percentage probability than what their slight risk, suggests. Just keep them in mind and coordinate those kinds of activities if you have time. After that, you or the DSS forecaster could then create and disseminate expectations to emergency managers, to other core partners, maybe through briefings, maybe through some form of a graphic like this. And then, of course, that clears a way to address the public using clear, concise, actionable information in whatever other way that you do. Maybe that's a different kind of a social media graphic, or maybe the single one will serve both purposes. But finally, then, we would advocate outlining your reasoning in a mesoscale AFD. That really serves to document your scientific thinking. It earns credibility with users, especially the savvy users, that NWS is a trusted source of meteorological expertise. It's the one place where you can talk science. And I feel like it doesn't need to be lengthy like this. It could be maybe 2, 3, 4 sentences. But I think there's real value in having that happen to reveal your insights as the event. So there were also 2 other areas on that same day for which effective analysis provided really valuable insights leading to enhanced IDSS. But in the interest of time, you guys really want to have discussions. So I won't go into those. But I do think it's worth noting that with the advent of GO 16 and 17, new spectral bands are presenting capabilities to combine imagery into RGB composites that have really great mesoscale analysis utility. For like Chad Gravel, as you guys have probably already had briefings on, has done some great pioneering work in terms of utilizing the day cloud phase RGB for detecting imminent lightning in conjunction with GLM and ground-based lightning. And there's ways to use this and to use lightning or the day cloud or the day convection RGB to sort of diagnose particularly vigorous updrafts that might serve to corroborate or at least add confidence to your warning decisions. So, there's lots of ways we can talk about and unpack this, but I just wanted to, use that as a sort of, this is the kind of thing that we're advocating for. And the benefits to me are fairly clear. We improve our tactical IDSS by providing timely, precise, actionable information, especially in those information gaps between outlook, watch, and warning. We develop a higher understanding of mesoscale meteorology through practicing this. WFO forecasters are better equipped to interact with and collaborate with SPC, which is a huge benefit to them. I'm told that there are some forecasters, based on your conversations, maybe some in your offices, who are, I don't know, some may be skeptical about changing in this direction. Others fear that the focus on DSS is sort of diluting the science in our mission. But, I think we can all agree applying these types of skills to our mission requires a deep dive into meteorology. In fact, far more science than is typically required when editing grids or composing TAFs or something like that. So, although I didn't address it in this talk, there are also opportunities to use insights gained through mesoanalysis to convey information about evolving probabilities of specific threats, and that's something that we can explore in discussion. But that certainly drives better risk management decisions when you can do that effectively. So, as I indicated at the outset, the STI director is committed to supporting an initiative that extends the reach of those skills in the field. And specifically, our goal is to achieve the capability for every office in the country to develop a deep enough bench to have someone performing these duties whenever they deem conditions warrant. And but of course, there are some challenges to accomplishing that goal. And here are four of them right here. There's a tremendous interest, but there is a lack of consistency in how they're being applied, in the training needs, in the levels of training and expertise. There's a need for both a combination of training in the governing principles, in the conceptual models, and in exercises available to build practice and to build proficiency. There is, as I'm sure all of you are well aware, there's a limited availability of resources and expertise in the WFO, and the SU can't do everything. And of course, there is a desire, as Greg alluded to expand these practices of mesoanalysis and IDSS to other service dimensions. And that all makes sense, but again, it just adds to the complexity and the challenge of making this nationwide implementation work in a relatively short time. So, fortunately, there has been some significant effort underway behind the scenes to begin addressing those challenges and to create viable solutions. So we're not starting from scratch. I've engaged some people who were part of the mesoanalysis think tank, and some of them who participated in the boot camps. Certainly interested in your contributions if you're interested as well. But we've already got a start on a library of fundamental KSA materials, and it's important that they're sort of bite-sized and that they're created in a playlist so that they're customizable for local use, because your service needs and your challenges and even the hazards you face most often vary depending on your geographical domain. We are already beginning to discuss the development of some cloud-based interactive DRT cases. These will probably initially be led by OPG, but we want them to be facilitated by SME teams, to build them and to walk through guided exercises where there is diagnosis, there's discussion, there's collaborative problem solving that's very realistic and job relevant. And we want to charter a group to, well, actually, I'd like to begin by gathering information from some of the experiments that took place in your area, in Kentucky, in the Northern Plains, in North Dakota, Minnesota, in particular, in Oklahoma and West Texas, where you've done these multi-office collaborations and dedicated chat rooms. But if we can figure out a way to make that work in a way that is value added and not just another burdensome thing to monitor, then it certainly has some potential to be a good learning experience as well as a good opportunity to share insights in a collaborative way. And then other things like post-event discussions, blog posts, mutual aid teams, road shows are at least possibilities, but I won't say any more about those. So this is the last slide. We do have a commitment all the way up to the STI director to achieve national implementation. The STI portfolio is dedicated to championing this, to funding it, and to shepherding it through. The goal is to achieve a pretty deep bench at every WFO that wants to invest in it within the next 5 years. And I think in the convective realm, we could probably knock a lot of that out in the next one or maybe two at the most. I'm finalizing a white paper I had just delivered to the SSD chiefs or STSD chiefs. Yesterday, we've kind of been back and forth on a few different renditions of it, articulating the vision, and so hopefully get national endorsement from the regional perspectives. And then we'll look at chartering a SU team to sort of serve as an oversight board for the broader project, but there will be the sub-teams that take care of some of the activities that I described on the previous two slides. And by this fall, we'll form at least one or two teams, I think, to begin the whole think tank process like we did 2 years ago, but for service, some other service dimensions. Fire weather comes to mind as a good candidate as one of the next ones, but winter, aviation, marine, are also possible. So I'll leave this summary of ongoing activities on the screen, and I'll entertain any questions or have you begin some discussion.